perlin noise is a procedural texture primitive, a type of gradient noise transitioning smoothly from high, white values to low, black values. You can take those high and low values, multiply them by some arbitrary number. The bigger the number, the higher the amplitude. Think about what we did until now as a single layer. Then repeat that with lower density noise and a smaller amplitude as a second layer. Do that again with even smaller values, once more to add some extra detail, and again if you're feeling a bit cheeky. But that's not all that impressive. Everyone does that. Here is some great explanation from Sebastian, this guy, and here is some great use case by Dani. I could just go the old-fashioned way of just stacking those noises on top of each other and hoping they will look good. Or I could go the alternative way of stacking those noises on top of each other. But Jeremy, you just said the same thing twice! The difference is in the hope part. I don't want to hope for some interesting formations, I want to know that there will be some interesting formations. So how do I achieve that? I don't fucking know! I'll be using Unreal Engine because it makes things go look nice. To start somewhere, I've whipped up some initial infrastructure for stacked noise generator and some tester class to visualize its output. I've done some research about inline instantiation of objects to make it work a bit nicer, only to scrap it like 20 minutes later, but don't worry about it. After that, I implemented a base noise layer that I will later on use to build some more complicated structures. Finally, I could add it all together, place noise layer inside noise generator and noise generator inside a noise tester, and yeah, the origin here, dots not here, dots here, here?
Well, leave me alone, mate.
Ah, here they are. We can see that the noise layer actually worked because some dots are higher than the others one, making it look a bit wavy. I've moved them around to attach them to the actor instead of the word origin. Then I've added some noise properties validation to increase performance a little bit, added amplitude multiplier and played with values for a little while. And then I realized, wait a minute, I don't really need all those variables. Perlin noise has like 3 things I need to define. After studying values a little bit more, I've come up with some nice looking bumps and made some animations and Then I've moved the origin point to the center of the mesh to make it animate nicely from the center. Played a bit more with the animations and came up with some nice results. As I was working for a while now, I've decided to look a little bit more into how others do procedural generation. I'd really like to introduce some water erosion into the landscape. It makes even nice landscapes look even more incredible and realistic. But that's a problem for future Jeremy. At this point I really wanted to see a little bit more into the landscape that I'm generating, but the size that I've been using for now wasn't really cutting it, so I had to optimize the debug drawing of my point cloud a little bit so that I could draw more of them. And so now, instead of drawing all of those points frame by frame, all of them at once, I'm drawing a bunch of them like row by row and storing them, keeping them rendering for a while, and that way I have no issues with drawing 4 times or even more than I used to. And then I started making progress. Psych! I would go on another tangent to separate all of my tools into a separate C++ module. Good freaking job, Jeremy. And then I've come back to my senses. Then I fixed the issue of me being a dumbass and defining all of my layers as only positive values, which meant that by natural distribution, if I take a median of between 0 and any positive number, if I add all of them together, the median going to be something positive. which is bad, because I want the origin to be in the center, which means I need the values to oscillate between the negative and positive ones, and median being around 0. Here is another neat animation I made after I fixed the height issue. That's what I call a great fucking... What do you want? What progress? I'm making so much progress! Okay, fine, I'm totally not stalling because I lost like a few hours of footage or something and I need to rework everything just to have some recording. So yeah, everything you're seeing here now is just me recording a rework of what I did earlier, but that doesn't matter because it was really a terrible piece of code. So here is the idea. I want to build a graph flow that indicates how the noise should behave at any one point. This should allow me to define regions of space that will behave differently than the other spaces. I can just take some region defined by some noise function, yes, the perlin noise function, and multiply that by another region. Now, if those noises are overlapping, those values will be higher. If one of those noises is nearing 0, the other one will be multiplied by it, causing it to also be near 0. So I can use this principle with various different nodes to have really different behaviors, defining various operations and being able to manipulate the entire landscape however I want. So having that in mind, what I need is an operation which can return something, a result of this operation, which can be then accepted into another operation as its argument, which then will be returned as an output of that operation. So I got an idea of making a noise operant object, which is just a container for one function. Like here, literally just one function, one virtual function. This means that this object then can be inherited, polymorphed, and each instance of this noise operant can have different behaviors, which means I can just stack them inside of each other and then ask them about their noise value at given point. I've then defined some operands, each having different logic and a different behavior, some manipulation, addition, subtraction, blending, pinching, stuff like that. Now that I got this toolkit of those operands, my graph that I can place them on, it's really the end of coding part. It's very simple. Now I just need to build some logic based on which the entire noise landscape will be built on. Sounds easy? Welcome to the end of the video, but please stay a minute longer. I planned on going deeper into the topic in this video, but it already took me a few months in and out of work to get it working and to edit the entire thing. So next time I plan to work with the tools I've just made to generate some cool looking landscapes and also generate the procedural meshes out of them. There also might be some shaders work involved, so subscribe and stay tuned if you're interested in that. In the meantime, let me know if you liked my cut or my video, and if you'd like to get access to the code I just made. It's a bit of a mess right now, but if you really like, I can clean it up and push it somewhere. Thanks for watching, and I hope I'll see you next time.